the creative process now all depends on you. So like me, I can show you an example of a main.h file that I have here. You can see here, this is main.h. And if I v into main.h, you see it contains functions. Look, these are functions written. These are user-defined functions. These are not functions that came with the C programming language. These are functions that are used in ALX projects. You will still use them too when it gets to your turn. So with that said, let's quickly go. Now, what is stdio.h? I've already said that it's a header file that has necessary information to include input output related functions, so on and so forth. Okay, the main function. The main function is a special type of function. I've said that it's the entry point of a program when execution begins. It is what communicates with your operating system. It is what communicates with your operating system to run the program, to run the codes that have been written inside of it, inside your program, to run your source code. So your main function is being expected by the operating system. The operating system expects your main function so that it can execute the codes that are inside of it. So it's not like every other function. It's a utility function. It's a how do I put it now? It's a function that you cannot do without. You cannot write a program without a main function. And I may use an analogy of all footballers. If the other functions are footballers, the main function is the football pitch. So every programming that you do is done in the main function. Every programming that you do, every coding you do in the C programming language is done in the main function. Statements. Statements are logical units. You're thinking what you want to do. In this case, I want to print the statement, my first line of code. So what can do that for me? A function called printf. Printf is a function which is defined in the header file that I just included, and it prints everything to the screen which is given inside the double quote. So that is what I want to do. So you now, in your own case, when you're writing your code, your program is what tells your rather your statements are the logical units that tells the computer what you want to do, that tells the computer what to do, what the program is doing, if you understand what I'm trying to say. So whatever idea that you have is being expressed via statements. It's being expressed in statement, and every statement, every logical unit must end with a semicolon in C, and we are seeing the C syntax. Every of your statements must end with the semicolon. So in this case, what I wanted to do with my program was to do what? Was to print out my first line of code. That is just what I want to do. So I can't call my mom to do it. I can't call my brothers to do it. I have to use a function. Remember, functions are workers. I have to look for the worker that can do that job for me. And the printf is the worker. He's not the only worker that does that, but is the most popular worker that will give me what I want. Is the most effective worker rather for this particular work. And it's inside the standard.h header file. So that is just it about statements. You learn more about that as we continue with projects. Now the return value. Every function returns a value. That is the reason why when if you see the line of code that we did here, we said int. Int here is not int, it's called int. It's called integer. It's a type of data. There are different type of data, and every function must have a data type. So int is a type of data, and by writing it in this particular place here, when you are declaring a function, it indicates the data type of the value that is to be returned by the function. In this case, the main function returns 0, and like you and I know, 0 is an integer. 0 is an integer. So that is why it's here. This is a return type, the type of data that the function returns. This is main, is the name of the function. Void is the parameters, which is the input that is to be used in the function. But the main function does not collect input. That is why it is written as void here. Otherwise, you would have seen otherwise you would have seen a data type here, like int also, and then a name, the name of the parameter that, or rather the input, the parameter. The parameter is an input, is also a variable, whatever it is that you want to think about it. Parameter is an input, parameter is a variable, parameter is a parameter. Just for the sake of clarity, that's why I'm using different words for you guys. Pick any one that you want to use. So then the questions, so on and so forth. We won't go into that. We've done that before. Study the slide, study the questions, and answer it. Let's quickly go on. So when we have written our C program, there are processes that it has to go through for it to become an executable file. I'm going to explain this. This is very important. You must not forget this because it's going to be part of your journey as a C programmer. Every C program file goes through what we call a compilation process for it to be recognized by the operating system as an executable file. Maybe that grammar is too much. Every C program file must go through a compilation process for it to be recognized as an executable file. What does that mean? It means that when you want to eat meat, your teeth will have to, chew it before it can pass through your throat and go into your body. So this is like digestion. The compilation process is like digestion. You have created your source code, which is the code you have written inside your program file. This was, I'll be trying to join the meeting but couldn't, though I accepted the invite. Okay, use the link in the shared all right, so let's continue. Now the compilation process is what translates your source code into object code. The compilation process is what translates your source code into object code. You see, this particular statement now we just passed it now in my own code when we're talking about static library. By the time I studied static library, I understood the importance of this particular session. So if you don't take what we are doing serious, if you don't take notes, if you do not try to understand what we are doing now, you might face some difficulties along the road. I will quickly um, explain what a source code is and what an object code is before I try explaining this process. A source code, this is the code you have written. The source code is the code you have written. Let me give you a very graphic example. Now, I want to take a C file, right? Any of my C file, let me say books.c. This is a program I've written to help printers to calculate the number of papers that are required to print any project, any book that they want to publish. The number of papers that will be required to publish a book. So As if now it's a simple printing calculator. Very, very simple. If I add a graphic user interface to it, if I add a graphic user interface to it, I'll be able to create a program that any printer in the world can use to calculate the number of papers that it will need. I can put it in Google Play Store. Printers calculator. We calculate the number of paper that you will need for a cover back book. So a hard cover book. So now this is my source code. This is also known as the source code. If you see here, I've written all this stuff. It's called the source code. But now the computer does not understand this language. It doesn't understand this. The computer does not read all of this stuff. I have to convert it to what we call an object code. The object code is made up of binary, ones and zero, ones and zero. All of this will be converted, both the functions, everything will be converted to object code. That is what the computer will have to read to execute the program, to make it that is to run the program. So let me just show you what I mean by that. Let me go back and let's take an example from here. Compiling to create an object code, the assembly and all this stuff. So we are going to do one after the other. The first stage of compilation is called the pre-processing. The pre-processing stage is not really the compilation stage, but it's like a like a preparation. It checks the file if all the files that have been included are part of the header file. I mean, if all the functions that were used is part of the header files that were included. It checks to ensure that everything is okay. If the syntax is right, or so on and so forth, it just checks all of those stuff. So we are going to do that quickly now. We are going to take our file and take it through the pre-processing stage as gcc-e, then /o, then whatever. If you see, it ends with a .e extension. Let's go. Let's see. gcc-e books.c/o output to books.e. gcc. Okay, book. Instead of books.c, I want to use book.c. Sorry. Let me correct that. Books.c. Alright, it's done. So I'm going to look for my books.e file. It should be somewhere here. Where are that? Okay, look. Guys, you can see books.e is available. It was not here. If you see here, books.c, there's no book.e. But now I've created this preprocessed file called books.e. Now let's look what is inside books.e. This is not what I planned, but we just have to quickly do this stuff. Look, if you see, it contains macros, it contains header files, contains other information that surrounds the file. Now, if you want to think about programming as just the source code that you are writing, you'll be wrong. You will be an incomplete, unequipped, unprepared programmer. You have to know that your source code contains your idea, but an idea without infrastructure cannot become a reality. So there are other infrastructures that are like utilities that support your idea, that supports the code that you are writing. So that is why that is what this pre-processing stage does. It just go to check that okay, everything is all right, every infrastructure is in place, the header files are in place, the bits, whatever it is, they're in place, so that is what it does, and it brings it here. So let's go out of this place. Now we are going to the next stage called the compiling stage. The compiling stage, gcc dash s lo.c dash o lo.s. GCC dash s, that's the company stage. So we're going to look what's inside there. I'm expecting object codes. I begin to love object codes so much because when I understood what everything meant, everything is actually zeros and ones. GCC dash s books.c dash o books.s. Okay, so let's look. I've been created. You can see it here. Books.s is here. Look at it where my stuff is. So this place has become too crowded. Let me clear it. Let's VR into books.s. So if you look here, it contains every statement that I used, every function, everything, placeholder, every single thing. This is how the file is to be executed by the operating system. Although it will not be executed like this, like in written words like this, human language like this, in the syntax of C programming language, it will be executed in binaries, but it is going to execute in this order. Look at it: file, books.c, text, session, blah blah, rows, string. This book we execute everything like this. If we go down, okay, I don't want to go down because, but that's just what it is. Then the assembly stage. I think this is one that actually does the object code thing, that translates source code to object code, and it has a -c flag. Just quickly run through this stuff quickly. GCC -c books.c /o /o, okay, /o books.o. Okay, one of my favorites. So let's VR into books.o. It has already been created, no need to look to save time. Books.o. All right, binaries, zeros and ones. You can see this is what the computer understands. Now we are speaking the language of the computer. So if you know, like I said, I want you guys to think now, please, everybody that is here, just understand this thing. Everything that you will ever write or that has already been written, every function, every variable, every what's it called, every number, everything at the end of the day becomes binary code, becomes object code. The functions you are going to use in your program will be translated into binary code. Your own program, your own source code, they'll be translated into binary code, that is object code. The functions, like the header files that you are going to include from the standard library, the header files you are going to include into your work, they will be translated into what? Object code, via this process, this assembly process. The source code of your work will be translated into what? Object code. Now, when this has been done, all the object codes of your work will be compiled in a file. Although we have not reached that stage now, but they will all be compiled, collected, gathered together in a file called a static library. It's called a library. All this is your file now. All these functions that you are using, everything, the variables and the symbols, after they have been translated to object code, this kind of thing, binary, zeros and one that we do not understand, each of those .o files, like this one is a .o file now, Look, it's a .o file. Each of these .o file will be compiled into a particular file now called a library. Now, this library will be linked into your own program. Will be linked together with your source code. They will join together, married together, packaged together, munched together, glued together by what we call a linker. And that takes us to the final stage of the compilation process, which is called the linking stage. The linking, this is it, gcc lo.c-o lo, the linking stage. When this linking is done, is completed, the output is the executable file that the operating system is going to run. So we want to do the linking stage here, gcc books.o. You can name it any name you want to name. Let's name our own bks. So bks has been created. Bks is now an executable file. How do we know? Let's look for bks here. Look at it, it's in green. It's an executable file now. Inside of bks, can we v into bks? I don't know. Let's do. I've not done that before. Look, inside of bks is what? Binary. Exactly as I've said. All the functions, everything has been linked together. Your source code have been joined together to become this. So inside here now is your printf. Inside here is your word that you wrote. Inside here is your include standard.h. Everything that you did has been linked together, munched together, married together. So what the computer does, according to what it does, it will be looking at here. It knows what is here. So it will look at the place where you use printf, right? So it will go and check where printf is here. Okay, printf is here, and collect printf and use it to do what you want it to do. It will look at everything just here. It's computer thing. Let's just think about it. It's crazy. You can't even do anything about it. It's called machine code. So that is what is done in this compilation process. First of all, the preprocessing does its thing. It checks that everything is on point. The compiler, creates everything in the order that is to be executed. The assembly converts it to what? Object code. Converts your functions, everything, into what? Object code. The while the linking stage links all the libraries that contain the functions that you have used in your source code to your source code to become one, to become a file, to become a program, to become an executable file. So that is that for that. Let's go on quickly. Oh man, time is far spent, but we are still, the time I budgeted for this is still on though. Okay, we have talked about this. Is there anything again? Okay, I've talked about it. Linking is a process of including library files into our program. Okay, I've said that library files are some predefined files that contain the definition of functions in the machine language. So all library files are in machine language. All library files are in machine language. Take note, please. You will need that later on in the years ahead. So this is a flow for this. So that's that for the whole introduction into C and all of that. So we talked about the header file, we talked about the functions, we talked about all of those things, right? So now we are going to go deeper. Please, if there's any question, if there's anything that is not clear, you can ask a question before we go deeper to the next section for today.
Hello, brother.
Wait, first, let me stop recording. 1 hour has gone.